Again, this is Jack Rymack. I am going to be your presenter today. Today's topic is Softree Optimal minimizing corridor earthwork costs through optimization. The demonstration will take approximately about a half an hour, 25 minutes to half an hour. Thank you very much. I will start. Just going to start with a short PowerPoint for this presentation. You are muted. It's not that we don't want to hear from you. You have a question and answer panel in front of you. Every so often, I will look over to see if there's any questions, and I'll go through the questions as we go along. So feel free to ask questions in the question and answer panel. You are being recorded, or not you, but I am being recorded. This demo will be available to all people that have registered for the demo. You get an email link. We're going to demonstrate how to optimize the vertical alignment position for a rural highway project to produce the lowest cost design. That's the objective of this webinar today. Okay, how does it work? You get your existing ground information. You go put in a preliminary alignment, either by hand or you import it from other sources such as DWG or shapefiles. Get your cross-section geometry, and you input your costs such as cut fill costs, movement and loading costs, additional costs such as culverts, pits, pit opening costs, clearing and grubbing costs, and then you put in your constraints, minimum max grade constraints, minimum K value, fixed control points. Grade control points are places such as crossings, bridge crossings, culvert locations, any other location that you might want to fix the elevation or the grade. You might want to put in some full bench sections or all fill sections. Material movement direction. You might want to constrain the material movement direction, whether it's going to be downhill or uphill and downhill or whatever. You guys decide. Once you get all your constraints, all that information, you put it through the optimizer and wait a few seconds, and out comes the optimal alignment. Plus the costs will be optimized, as well as you will also get earthwork movement schedules. And we're off to the races. Let me just minimize this and start with this. Okay, here's a typical alignment that's been done by hand. You can see that it's not a great alignment. There's a lot of cut. I guess I could fix some of this cut. You can see the cost of this road over here in this alignment panel. The bottom of the alignment panel right here where I'm pointing. It's $364,000 to build this road based on cut cost. Let me just see some of the costs that we have in here. Cut costs, excavation costs, embankment costs. It's pretty cheap material. Hauling costs and loading costs. You can change those costs to whatever you want. We're just using this common material to as a material that we're going to be calculating our cut costs, fill costs, movement costs, and hauling costs. So based on those numbers, you will get a total cost of $364,000. Those costs split up into its cut costs $151,000, fill costs of $12,000, hauling costs of $200,000. Let me show you how to, I could just tweak this manual design a little bit by moving the alignment up and down. First of all, I want to make sure that I've got auto costs on. Calculate that. You can see nothing has changed yet until I move my alignment on. Move my alignment around. Move it up a bit. you should see the cost change in the alignment panel. See, it's dropped drastically. It's because these cut costs are overwhelmingly overwhelming part of the total costs. The fill costs don't take up too much. So moving the alignment up a little bit more will give me less cost, give me that cut, like less cut, and hence drop the cut costs and the overall cost. Now let's go on to vertical optimization. No questions yet. I'm just going to proceed. Show you how to optimize this road. Try to get rid of some of this this cut that I have going on by optimizing it. Start a new optimization. I'll just call it Optimal. The description Optimal. And go to my standards. I'm going to change this to curves and tangents. I want my curve length to be 100 meters long, tangent length to be 100 meter long, minimum. K value is going to be 10. This is going to be a rural low volume road, so K value of 10 is appropriate. For sag and crest, min max grades, that should be good enough, minus 10%. For minimum grade, maximum grade, 10%. Make sure that I have that edited, and control points. So I talked about this at the start with those slides that I showed you. You can put in control points. I'm just going to put a control point at the start of the alignment. Don't want to move the start of the alignment up and down because it's probably coming off an existing road. Don't want to fiddle around with that too much. And going to leave the rest alone. I could put in bore and waste pits if I want to. I'm not going to. Put in bore and waste pits if I want to. I'm not going to. Just want to just run this. Again, our unit costs are going to stay the same. So that we compare apples to apples and not change the cost too much. And we're not going to put any constraints like full bench cuts or any kind of directional movement. Just going to let it run based on the standards that I gave it earlier. Process. So within a few seconds, you should have a an optimal alignment. Hopefully, to be better balanced, a better balanced road, and also the cost should come down. Cross my fingers. I hope everybody can hear me pretty well out there. I'm just going to let this run and just stay quiet for a bit, and we'll see the final result within a few seconds. Okay, it's found a result, and this number that you see here changing rapidly, percent gap is the optimality gap is the at most it will be the amount that it's going to be at most away from optimal. We found a solution. It's dropped the cost down from 300 $251,000 to $106,000. I'm going to set this current. You see it's nicely balanced road right now. Not a lot of cut or fill. Nicely balanced around the zero, around the balance line, which is here. Okay. All right. So I'm going to show you something that has changed a bit. First of all, I'm going to show you how it used to be done. Whenever you wanted to change the horizontal alignment, you had to rerun the vertical alignment. Now I'm going to show you first how it was done, and then show you the end result of. We do have a horizontal optimization technology that will move the horizontal alignment for you, and then rerun the vertical. I'm going to show you. You used to have to move the horizontal alignment around and then rerun the vertical. Let me just move it a bit and then just show you how to run that vertical again. So I'm going to minimize this. So every time you move the horizontal around, you have to go and reprocess this. You can see that by just moving that a little bit over, I ended up with a lot more cut. I'm going to process again and try to get a better vertical optimization. After I do this, I will show you how to what the horizontal optimizer looks like. While we're waiting for this, if there's any questions out there, feel free to ask. I know that there was somebody that said they couldn't hear me before. Can you hear me now? Okay, let's just wait for a few seconds while this is running. All right, it's going to be done in a couple of seconds. Again, there's that optimality gap. What that again means is that at most you are away from, that's the number that you, the percentage you are at most away from optimal. So we did find the best balanced profile, and the cost has successfully been found. And there's our new, there's the mass haul diagram as a result. Okay, so previously you did have to move the horizontal alignment around and then rerun the vertical. Now you don't have to do that. I'm just going to show you what the result is. I'm not going to run it because it will take a long time. So basically you have the original vertical alignment and then the optimized vertical alignment. What you do is you have to, let me just delete. I'm going to go back to the original. Set the original as current. Delete that. So what you have to do is you have to set up a new, I didn't delete it for some reason. Let me just go back to this. Set current, and then delete that again. There. So now the original is back. So what you have to do is you have to set up a new horizontal alignment. And I'm going to call it optimal, horizontal optimal, H-A optimal. And then you have to run, you right-click, process the horizontal optimization. And there are 4 curves available to optimize. You can select them all, or you can select 1 or 2 or 3, whatever you want. So this part of the dialog box over here, tells you how far you can move offset in the X direction and how much you want to move in the Y direction and what's the minimum radius. I'm not going to talk about the rest of the dialog box. Just want to tell you that you can, we're setting up as a 5 by 5 meter grid. So I can move 5 meters in the X direction or 5 meters in the Y direction. Any of my curves. I'm not going to run this because it will take a little while to run. I'm just going to show you the end result. Again, I'm going to open that up. So this is the end result. You can see that the current current horizontal alignment is actually the optimized alignment, which is the dark red one. If I want to set the other one as the original one as current, just go into that. I click on that plus sign. Let me do that again because I did it too quickly. Click on that plus sign. Go back to the original. Set that as current. Okay, so now it's flipped over to this alignment. So it actually moves this IP up to approximately, it moved this IP right here. You can see that pink faint box right here. So it moved this red box from here to there to optimize the horizontal. So again, just to reiterate the software with the horizontal alignment optimization, it takes the horizontal, moves it, re-optimizes the vertical, and then that might take a little while. You might have to run it overnight. It might take a couple of hours. You guys play around with it and see what you think. And the costs have definitely dropped from the original. Let me just recost this. Something is out of whack here. The original road was $358,000, and the optimized both horizontally and vertically road is $128,000. Yeah, it's $128,000. It's a little bit more expensive than just a vertical optimization because it had to, it's moved it into a different position, so it's a little bit more expensive. Any other questions out there? Okay, let me just reiterate what I did. I brought in an existing alignment. Let me just open that again. I'm just going to go really quickly through it again, just so that everybody gets the idea. I brought in an existing alignment, a manual design that was done by me. Let me just close this down. I don't need that. I'm going to open up my existing design. There it is. Set this as current. And delete this. So what I did, like I said, I had an existing vertical alignment. Which cost me around $269,000. I went through the optimization process, set up a new optimization. Set up some standards, kept the default for the bottom part, but set up my own tangent, curve tangents, and curve lengths and tangent lengths. and a control point at the start of the alignment, and optimized. And then I showed you the end result of a horizontal optimization. Horizontal optimization will be available in version 9. Vertical optimization is available right now. Horizontal optimization, the software takes the original horizontal alignment and moves it a certain X and Y direction to the user's specifications and a minimum radius, and moves that alignment to an optimal location, and then reruns the vertical and gives you the lowest cost vertical alignment based on that new horizontal alignment. It's pretty nice technology. We are pretty proud of it. I hope some of you get a chance to try it out. Other than that, I will call it a day, and I welcome you all to join in on some of our other web demonstrations. We usually have these every couple of weeks. The next one I think is on culvert replacement and road design over top of the culvert. So culvert replacement, fish passage. It's in probably in a couple weeks. We have changed our demos. It used to be Fridays a long time ago. Now they're Thursdays. Find that Thursdays are a little bit better because people end up showing up to the demos. Okay, just as I'm finished talking, the optimization has been done. Let me just set that as my current. You can see there's that balanced road again, just as it was before. So the software moved the alignment up and down until it found the best cost. Anyway, thank you very much, folks, and we'll see you in a couple weeks. Thank you. Bye-bye.